But now we're going to see how the logarithms apply in equations. And basically, there's more rules within these equations. So, first one, okay. So, we're just going to try to apply our knowledge of what we just learned for logarithms to the equation. So, it might look a little bit weird, but so for all these equations except for this one, except for this, I'll highlight it, is we're basically gonna, well, except for this one, but if you just see a log, or sorry, let me add this to another. So, okay, so log, if we just see, so log of x is going to be equal to log 10 of x. We don't have to, we can't always assume that if it's given a specific value, but that's always what, if you just see a log and you don't see anything else, you can assume it's log base 10. So, yeah, log base 10. Base 10. That was a bad base, but that's fine. Okay, so we have this equation here, and what we're going to do is remember, this is log 10. So, this, even though we have what the logarithm is focusing on is in two terms, we're just going to stick with our original way of interpreting it. So, we're going to take the other side, remember, the other side of the log. If there's both sides are logs, there's different ways to do it. But the other side that doesn't have a log, and we're going to plop it on the base of the log, right? So that turns out to be, and then we're going to move this equation, or what's the log's focusing on the other side. So this is going to be equal to, this is going to be equal to, remember, we're going to plop the 2 on the 10, so it's going to be 10 to the power of 2, 10 to the power of 2, is going to be equal to, I'm trying to write this, okay, is going to be equal to 3x minus 2. So, now we can just simplify it down. 10 to the power of 2 is equal to 100. Oops, that looks like theta. 100. So 100 equals 3x minus 2. We're going to add the 2 to the 100. Minus it, sorry. And so we get, we add it, sorry. Okay, sorry. So we get 102 equals 3x. And if we divide, I'm getting into other shapes. If we divide by 3, we're going to get, it's 102 divided by 3 is going to be equal to 34. So we get x equals to 34, and that is our final thing. So what we just did here is we just, remember, our original strategy of doing, we plopped the 2, or the other side of the equation, onto the base of the log, or the tiny number at the bottom of the log. And then we set what the log was focusing on to the other side of the equation. So we got, to put it in terms of what I'm explaining, we're going to do log base to the power of the other side is going to be equal to what the log is focusing on. So you can jot that down because that's kind of a little bit of helpful. It doesn't always apply, but that is helpful. So I'm just going to go here. I'm just going to condense this. Oh gosh, what is happening? I'll condense this so you can still see it, but we're going to have space. Okay. Wait, sorry about this. Okay. So the next one, you're probably thinking, what is this? Like, what is ln x equals -3? So, another huge rule. So, it's going to be that ln, or natural logarithm, is equal to log of e. So, e is a mathematical number. Is a mathematical number that is approximately equal to, it's a bad thing, 2.71. And I can provide a mini short in the description that shows what e is equal to, or how its e is, like what the idea of e is. And so I can focus on that soon, or I can add it in as an extra clip at the end of this video. So, but I really want to focus, I don't want to get you too distracted, so I'm really going to focus on this. So keep in mind, log, or E is going to be equal to 2.71. And ln stands for natural logarithm. And that's just log of E. So we can put this as log of E of x equals -3. And just as always, even if this seems pretty complicated, we're going to go back to our original rule, and we're going to plop the -3 on the E. And we're going to put the x on the other side. So we get E to the -3 equals x. And if you know negative exponents, another rule, negative exponents basically flip the equation, or flip the side it's working on, or flip the number it's working on. So let's say we had 5 to the -1. It's not a 5. 5 to the -1, or 5 to the -7. Let's just do that. That's going to be equal to 1 over 5 to the 7. Or, see, we flip it. We take the reciprocal. Or 3 to the negative, let's say 3 to the -2 is going to be equal to 1 over 3 to the 2, or 1/9, because we simplify it. So that's basically negative exponents and their rule. Okay. So now we're just going to delete this over here. Sorry. And so now we get that we flip the E, remember, negative exponents, and so we keep this exponent here, but it's now in its positive form. So E to the power of 1/3 equals x, and that's as far as we can simplify it. You can say this is, let's just say E is approximately equal to 2.7, or let's say yeah, I actually think this is good. You can calculate it. You can put it on your calculator. Do 1 over 2.71 to the 3rd power equals x, and you get x. So all we have to do is just plug in E, or the value of E, and we get x. So that's, remember, although this looks super complicated, well, maybe, it depends on what you've been doing, but although this looks pretty complex, you're just going to stick to the original value, and we're going to put, sorry, I can write log E. Or actually, no, well, we're going to plop the 3 on the E. Technically, this says ln, but you're mostly going to get it in that form. But it's good. Ln is equal to log of E, or log base E. And so we're just going to we're going to plop the -3 on the E as an exponent, and then put the x on the other side. And that's going to be how to solve it. Okay. So we've done that, and now we're going to do even more logarithms. There's only 2 more, don't worry. And we're just going to get more proof. I'm sorry, and we're going to put more rules and apply more rules. So this one, it looks crazy. And you might say, wait, Math Mule, you can't plop this on both of them. Can we even do that? What you want to do is, whenever you see a plus sign, so there's another rule. So this rule is log of, let's say, log of x plus log of x is equal to log of x times x. So what you just do is you add, or you time, whenever the logs that have the same base, you want to times them. Whenever logs that are being added and they have the same base, you want to times them. So in this case, log 10 of x, remember, 10 is the one you should assume if there's just a log and there's no base. So log 10 of x plus log 10 of x, is equal to x times x. Or you could just let me just add this. So log 10 of x times x, or log x squared. Actually, right now I just want to give you a quick exam, or not really. But you can simplify this because I don't really know right now, but what is log Oh, actually, another rule. Okay. More rules. So, to find out what this can be, another rule, I'm going to, sorry, if the rules are getting too much, I will sum it up at the end, if you're willing to stick around for it. So, rule, if you have log of a to the power of b to c, right? This is going to be equal to c, the exponent on the term that the log is focusing on, c times log of a, or log base a of b. So, we're just going to plop the exponent on that's on the term of the log, and we're going to times the whole log by it and remove it from this area. So this is another rule that's very important. And so if we're going to apply this to this equation, that's going to be equal to log, right? And what we're going to do is we're going to move the exponent on the term, on x, and we're going to times it by the whole log equation. We're going to remove it. So we get 2, because that's the exponent. Like, let's say this was a 3, it's going to be 3. But right now it's a 2, so it's going to be 2 times log 10 of x. And if you want to go even further, simplify it even further, what you're going to do, let's say you have, let's say y. Let's say this is all equal to y. What you're going to do is you're going to divide, you want to get rid of this times 2, so you're going to divide both sides by 2, and you're going to get log 10 of x is equal to y over 2. Then, remember, we plop the other side without the logarithm on the log base. So we get 10 to the power of y over 2 equals x. Now, remember what I just said. Remember the rule of fractional exponents. Although this has a y in there, we still want to take it as a normal number. So basically, remember, denominator is what it's getting. This number is getting square rooted by. The numerator is what the power that this term is being raised by. So we're going to do 2. We're going to bring the 2. And we're always going to do square root here. Square root. And then we're going to do 10. We're going to bring the 10. And then we're going to do to the y equals x. And that's mainly that's all you can do. If the y had actual value, then you could plug it in. So let's say, sorry, I'm getting super sidetracked here, but I just love math. So let's say y equals 2. We have 2 to the power, or 2 square rooting 10 to the power of 2 is equal to x. Basically, if you have an exponent in the square root term, and that's the same number of that exponent is being what you're kind of getting square rooted by, so then those can cancel out. So for example, 2, the exponent, is the same as 2 of what it's being square rooted by. So that's just going to be equal to 10. So 10 equals x. And you can even prove this by kind of doing this equation out. So we get 2, and then 10 to the power of 2 is 100. So square root of 100 is equal to 10. So we still get 10 equals x. Okay, that was a lot. That was the quiz. Okay. So now we're turning to this. Remember, the rule, it was kind of a long time ago, I feel like it was. But the rule is that if you have a log that has the same base, remember, the log doesn't have to focus on these. The rule doesn't apply to these ones that the log is focusing on, but the log's base. So let's say the base 10, right? So these both have the same base. So what is it going to be? You can answer it. All right. Hopefully you got it, but that's fine if you didn't. But, okay. So this is going to be log. We're going to take the first one, and we're going to multiply it by whatever is inside the other whole value of the second logarithm. So we're going to multiply x, which is the first logarithm. Sorry, I think I said algorithm. Sorry about that. So I meant logarithm. So then we get x times x minus 1. We're going to do the whole thing times the whole thing. So log of x squared minus x, because we're going to distribute here and we're going to distribute here, is equal to log 4 of x. And remember, so actually I haven't told you this yet, but if there's logs with the same base on both sides of the equation, then we can completely cancel them out. Because think about this. If we have 5 times 4 equals 5 times 4, then we get the same effect if we cancel out the 5, because both of the sides are being equaled or times by 5. So cross this out, we get 4 equals 4. And likewise with an x, we've got 5 times 4 equals 5 times x. What's gonna happen is we can just cross this out, right? Even though these terms aren't the same, we're gonna cross this out, because otherwise, if we don't, we would get 20 equals 5x and x equals 4. So we get the same answer. Okay. So likewise with this, we can cross out both of the logs with the same base, and we get x squared. And we get x squared minus x equals 4x. So this is called factoring. I don't want to go all through it because it's super long. There's a lot of ways to do factoring, but I can create another video if you want me to. Let me know in the comments if I should. So this is going to be equal to, we want to move the 4 in between the x squared and the x. Or actually not in between. We're going to add the 4x and the negative x. It's going to be equal to x squared minus 5x, because we're going to have, if we put this over here, it's going to turn to a negative, and then it's going to go to the add to the x. So this whole side is going to be equal to 0. It's kind of getting jumbled. So this is equal to 0. Now, if we factor this side by x, then we get, this is super jumbled. We find a factor of x, we get x times x minus 5 equals 0. So this is where it gets really tricky. So now we can just say we move this equation here, and we want to basically set one of these sides, one of these multiplication sides to 0. So for this parentheses to be 0, we're going to have x be 5, right? Because 5 minus 5 is 0. And we want to set this whole side to 0. So all we have to do is we have to basically find one value of x that would make either the x or the x minus 5 0. So we have x equals 5, or we could just times this parentheses by 0, which would equal 0. So x could equal 0. But surprisingly, x does not equal 0, because this is called an extraneous solution, where you get a solution, it makes complete sense, but it doesn't work in the original value. And the reason is that another rule, log 3 of 0. Because it doesn't make sense, right? Because let's say it's equal to x, we're going to plop the x here. We get 3 to the x equals 0, which we don't really know. So that's why you cannot do it. So that's why x is equals 0 is not an answer, and this is the real answer. So x equals 5. And look, that was not too hard. I just wanted to go super in depth, so that's why it took a very long time. So, boom. Now we're just going to finish number times these. So it's going to be 5. Number what am I talking about? So it has to be the same base, and they're both log 9. So it's going to be log of 9, and then x minus 5 times x plus 3 equals to 1. So, what you can do here is I'm just going to multiply it out. And so, yeah, I'm just going to do this. So we're going to, if we multiply these out, we get log 9, log 9 of x squared. And then we can times this by this, we're going to times this plus 3x minus 5x minus 15. So now what we're going to do is we're going to, equals to 1. So remember, this looks insane, but remember, we take that rule from all the way back in the video, and we're going to plop this onto this. So we get 9 to the power of 1 is equal to x squared plus 3x minus 5x minus 15. A lot of stuff here. And so we're going to move this 9 to the other side. We get x squared plus, or we're going to basically simplify these. It's going to be minus 2x, right? And then minus 15 minus 9. So if you add minus 15 plus minus 9 is going to be equal to minus 24 and equals 0. And this is another factoring example. Wait, shoot. Yeah, I did this right. Okay. So now what we can do is we're going to find what multiplies to this number but adds to this number. So that is going to be 4 and 6, and specifically negative 6 and 4. So we're going to get x minus 6, or you can do x plus 4, x minus 6 equals to 0. And if you set these equations as mini equations, we get x equals negative 4, and we get that x equals 6. And these are both not extraneous solutions. Sorry, I'll read this. These are not extraneous solutions because they are not 0. And there could be further extraneous solutions where you can't really, or wait, actually, let me just check. Yeah, so these are not extraneous solutions because none of these, when you plug in these values, none of them equal to 0. If we had, let's say, if we had x plus 4, and technically that wouldn't equal 4, but if we had that, then basically it would be negative 4 plus 4 which is 0, and then we would have log 9 of 0, which we cannot do. So that's why these are both the solutions this time. And boom, okay. We are done. We are done. And now, if you want to stick around, I'm just going to put in the values of x. Sorry, not values of x, what I'm talking about. The rules. So, actually, I'll just run over them just quickly. So, this little quiz. If you have log 10 of 10, if you have log of 10, you don't have any further information, then what would this be equal to? Hopefully, that was good. What we're going to do is we're going to put this to log 10 of 10. We're going to plop, and let's say it equals to x, so we're going to plop the x on the 10. So we get 10 to the x equals 10, which x equals 1. And that is the answer. So, thank you so much for watching. I want to thank everybody for getting me to 6 subscribers. I'm really happy about that. And comment down below, even if you didn't get to this, or you kind of thought this was a long video, comment down below what math you want me to do next, what math you want me to, what math you want me to do next, maybe some improvements I can do, should I make my videos a little bit shorter, or otherwise, what I can do. Thank you.